The problem that we're going to be looking at here is a little wordy, but still working with quadratics and parabolas in standard form. So in this problem, they're saying the height of a projectile fired straight up into the air with an initial velocity of 64 feet per second is h of t when it's equal to negative 16t squared plus 64t, where h is the height in feet and t is the time in seconds after it's been fired. The table represents the data for another projectile. So this is, let's call this projectile 2. We'll call this h of t projectile 1, since it was mentioned first. If you're taking physics or you plan on taking physics, this equation comes up again and again and again. This is not going away. You'll see a lot of equations that are set up like this, so please get familiar with seeing equations in this format. Of course, if you have any questions, let me know. So what this is asking, which projectile goes higher? How much higher does this go? So we know that this is given as a table. We know that we have this second equation. Having your calculator on hand is going to be crucial here. So if we plot this out, clearing everything, we have negative 16. I'm using x instead of t because t is just an input the same way that x is an input. So this is totally fair game, plus 64x. If we graph this out, we'll get the standard form of it. So as we see, this has a lot to it. We can't quite see exactly where this is going. We could keep zooming out and zooming out, but we really don't have too much of a precise measurement on where it's heading, at what time, and whatnot. So for this, we can actually modify our table. We see that it's going in a certain fashion, and we have some of the same values that they do here. So let's take note on what projectile 1 is going to look like. So this is going to be the same idea where this is t, this is your height for projectile 1. So when x is 0, the outcome 0, that makes sense. And we'll try to match the same values that they get here. So when x was 1, this was 48 feet up. Nothing can stop me. This one's all the way up after 2 seconds at 64. Notice that this doesn't quite have halves for us, so let's see if we can modify this a little bit. If we hit second and then window, you'll see this triangle table. If we change that to 0.5, so notice this is going in changing increments of 0.5, 0.5, 0.5. If we switch the table, changing to 0.5, and we'll start at 0 just because we'll see if we can get those values in between. So we see that when x is 0.5, the outcome's 28. We also see that when x is 1.5, the outcome's 60. So we start to note that this goes down a bit after when x is 2. So we can assume that this is most likely going to be our vertex at 2. So we can compare and contrast. So we can hopefully see pretty quickly that projectile 1 is definitely going to go higher because at the maximum height, we see that at 1.5 seconds, projectile 1 does 60 feet. So that's an easy one to answer. Projectile 1 goes higher. How much higher exactly? Well, we can hopefully agree that the vertex is going to be when x is 1.5 for both of these. If we were to compare and contrast the differences, so how much higher, we can take 60 and deduct 36. This is 24. We can collectively say 24 feet higher. And this is really measured at the vertex. So let's make a note on this. These are both vertexes. Or vertices, rather. So in addition to that, they ask us, what is the height of each projectile 2.5 seconds after launch? Well, we can hopefully see that this pattern is going to continue moving in 0.5 if we want it to. Since this is starting to come back to Earth, like imagine that at 1.5 seconds, it's at its highest point. And we can hopefully assume that this is also an axis of symmetry, assuming there's no wind and it doesn't randomly get kicked out of the air for some reason. Maybe a plane flies by and hits the ball or projectile. So we can assume that as it comes back down to Earth, we have points that we can just reference again. So after 2.5 seconds for the second projectile, we know 36 is the highest. It then goes back to 32. We can assume that it's going to go to 20 as well. So for P2, this is going to be 20 feet. For projectile 1, we'll assume it keeps going in this fashion. Or sorry. Did I copy that right? Oh, yeah. Now, this is a different ordeal. All right, I'm not going crazy. I really forgot to look at the actual vertex. So the actual vertex here should be 64 minus 36. This is a big blooper, but carry with me. So this should actually be 28 feet higher. This is still 20. If we continue with projectile 1 after 2.5 seconds, this should be 60. Which makes sense because when we check this after 2.5, it's 60. Sorry about that blooper. So